Okay, so you see my
Okay,
slide? Is
great.
everything okay?
Yes, it all looks good now. Yeah,
Perfect. So thank you so much, everybody. Let's see if I make it in a slide in share.
I think since it's a family environment today, everybody knows you here. I think we can skip the formalities and you can go straight to your
Yeah,
talk.
thank you so much. So hello, everybody, and sorry again for keeping you 10 minutes waiting in such hot weather. I can imagine everybody is weather, and it affected our performance. So I don't know why my computer, the speaker was started playing around and it was not working. But anyways, it's a pleasure for me to present my work to you today. And so as you know, I am directing brain-computer interface lab at University of Sheffield. And, I'm working with a number of colleagues in Essex. We do a lot of different activities, different projects, and you can see we work with EEG devices, with robots, with the VR headset, and our aim is to augment human performance, physical performance, cognitive performance by developing AI-powered closed-loop neurotechnologies, neural interfaces. We do a lot of BCI activities in the lab. And let me go to the next slide. And if I want to categorize the work that we do in the lab, I can say that we do a number of studies on human-robot interaction, human-machine interactions. We work some studies on using BCI for stroke rehabilitation. We are very interested in improving cognitive performance. So we have some project using neurofeedback and neuromodulation for improving cognitive performance, but also we have projects related to non-invasive brain stimulation, temporal interference to enhance cognitive performance. We are working on, different projects with different technology readiness levels. Some of the projects that we do in the lab, they are very low TRL, working on algorithms and computational modeling, but we have also some projects that they have higher TRL and they are in the stage of the commercialization. But today I would like to talk about another project that I am following and we are campaigning since last year, which might be a little bit different from traditional brain-computer interface that we do in the lab, and it is called Neurotech4All. So we are a group of clinicians, social scientists, engineers, BCI researchers that we work on this project and we are hoping to come up with a number of actionable recommendations, guidelines for clinicians, for researchers, for policymakers, for ethics committee to ensure that neurotechnologies that we are developing, they are equitable and inclusive. And when we talk about equitable neurotechnology, what do we mean? It means that the technology that we develop in our lab, they work well for everyone. So we don't come up with technologies that work for some people, but it doesn't work for some other peoples because of the demographics that they have, because of the skin color or the hair type that they have. We have different directions in this project. So we are working on areas that affect equitable BCI and neurotechnology, considering the design biases, considering the disparities that we have in research participation, and also considering disparities that we have in adoption of the technology. So if I want to give you more details, I'll go through each part one by one. So first of all, I would like to talk about calibration and design biases. And this is the challenge that we face from the first day this is the challenge that we faced in our own lab, and it was actually the first point that initiated this project. We had a project, a clinical trial to use brain-computer interface at home for stroke rehabilitation. Probably if you use BCI, I assume a lot of you are working on brain-computer interface is a technology that can be used for communication between brain and electronic devices, and it can be used for stroke rehabilitation. So our project, I'm not covering it in this presentation, but the aim was to use this BCI technology at patients' home. So we made the number of electrodes smaller, we made the calibration time shorter, and we were able to use the technology at home. The first patient that registered for our clinical trial was a gentleman who was really keen to receive this treatment. NHS usually doesn't provide any rehabilitation after 6 months because it is assumed that there wouldn't be any meaningful improvement. But we know in BCI that because of the way that this technology is designed, by linking brain signals and motor movement, residual movement, there are a lot of evidence that showed that even it is helpful, it is usable for chronic stroke patients. So this patient came to our lab, and he was a young gentleman, but he had African style hair. So we put the gel, we put the cap, but there was a big gap between the scalp and the electrodes. So we couldn't fill the gap. We put loads of gel, but the electrode, the connection was not good at all. We made the cap tighter. We make it much tight that he was not comfortable, but still we couldn't get a high quality brain signals. So after half an hour trial and error, the only thing that we could do is to say that, sorry, we cannot have you in our clinical trial because our technology, our EEG device is not built for your hair type. And I remember in the whole journey that I got NHS ethics approval, the panel, they were going through all my inclusion exclusion criteria to ensure that they are inclusive. But we never thought about our own EEG device. Our technology is not inclusive enough. And we know that this EEG device that we have, EEG is built for 102 years ago, but still a lot of devices with high quality that we are using in the lab, they are not built for hair with a thick curly hair. And and we are started wondering what is the problem, why we have this issue. In a lot of, studies that we publish, we mentioned that we excluded, for example, we recruited 25 participants. We excluded 2 participants because of the bad quality signal. So we put the blame on patients, on participants, rather than acknowledging that this is a problem of our technology. But the issue is that even solving this problem in terms of engineering perspective is not very challenging. I asked my undergrad student, and as you can see at the right side of the picture, she came up with different electrode lengths, and there are a couple of new companies that they are now working on different electrode sizes, different electrode types for different headsets. So this was initial for this project. And when I started wondering about different technologies that we use in brain-computer interface, we got to somehow same conclusion. I'm not directly working with FNIRS, but when I was talking with my colleagues who are using FNIRS, they were telling me that if the quality of the signal is not very good, if the participant has black hair, because a lot of light is absorbed by hair before penetrating inside the skull. So this is again another problem that we have in neurotechnology. So we have some inherent design biases in our technology. In our lab, we work a lot on TDCS, TAC, so general transcranial electrical stimulation, when we put electrodes on the surface of a scalp and we try to stimulate different part of the brain. And usually what we have, it's one size fits all. So we use the same amplitude for all the participants. So this is very black, one size fits all approach. But the issue that we have is that the skull thickness, the skull, the density of the bone, they are changing by age, by gender, and probably by race and ethnicity, maybe. And these factors can significantly affect how much in reality each person receives electrical stimulation. So you see now here the differences in bone density between male and female, and also how it is changing over the time when we age. So I had my students used computational modeling and try to simulate. This picture is coming from another paper, but it shows how much variations we have in those in amount of the intensity of the electrical stimulation that we receive from person to person. So it's the same dose. You can see some participants, they receive far more than other participants. And this is mostly because of the anatomical factors. We had in our lab, we had a teleoperation study working with BCI and VR. And the problem, it was about using VR, driving a machine and trying to go to different casualties to rescue different patients. And we wanted to see if biofeedback can help to improve the performance in this high intensity task. What we observed so we did our best to try to reduce motion sickness, VR sickness in our experiment. But the problem that we had is that anyways, it was a driving simulation. So it has some sorts of VR sickness, but we had far more dropout of women in our experiment compared to men. So we started wondering what is the reason that women are dropping more than men. Thereafter, we looked at our VR headset and we realized that the pupil to pupil, the distance that is built for our VR headset, it was built for average men population. So it means that not only, a lot of women, but generally people who are not fit into this average population, they are more susceptible, they are more prone to have motion VR sickness. So I said all these things just to tell you that we use a lot of these devices in day-to-day activities of our lab, in our research, but they may not fit for all people. They are not working well for everybody. And there is a need for us to acknowledge these problems of our technology, and thereafter, as a research community, think how we can calibrate for person-to-person variations, for variations across the anatomical factors. So these are just some examples that we observe from devices that we work. I was talking with some of my colleagues that are working eye trackers, and they faced similar problems. And and I believe that these are issues that we need to address at research stage before moving to the translation. So this part that I covered, it was more about design, the biases that we have in design. But the problem that we have is not only about design of the technology, but also we have a huge lack of diversity in the participation of our research. I don't know how it is in your lab. If you do any BCI study, how proportionate your participants are. But when you look at clinical trials on brain research, they are very biased towards white population. So, for example, we looked at the studies, global clinical trials in neuroscience between 2016 and 2021 across 47 countries. It was a huge number of participants, something like not 8,000 participants. 85% of the participants were white, and Black participants were only 1.6%. And given that we have, the bigger population is Black people, so it is risking us that we are building up new technologies, we are building up interventions that might be biased more towards white rather than other cases. We are working a lot, UK biobank dataset, which is the largest neuroimaging dataset, but it is 95% white. I understand that majority of these datasets have been have been collected in Europe and America. But even if you look at the distribution of population, for example, in the UK, we have 18% non-white population, but UK Biobank is only 5% non-white. So there is a disparity in this research that we do in terms of the um, demographic that we address. And it can be risky. So one of the risks that we had and we observed is that in the devices, in neuroimaging devices that we use in the lab, we see the problem. It's not, there are some design biases that we may not notice. And this is a big risk about future of BCI. If it is aimed to be used by patients, it may not be equally beneficial for everybody, and it by itself it can increase the inequality. So what would be the solution? How we can make our research more diverse? So what we did is that we try to reach to community centers. We go and we talk with Iraq, Somalian community in Sheffield, with Congolese community in Sheffield, with ShipShape, which is mostly covering South Asian communities. We went to a number of mosques to understand what are the barriers for people from different ethnicities, people from diverse backgrounds to attend brain research, to attend BCI research. And we learned about what they mentioned. The main barrier was lack of awareness about these research going on. They were telling us that they feel that this research is inaccessible. They don't know what's going on. Most of the research is in hospitals or in universities, and these venues are not necessarily accessible for them. They were telling us that people are coming and giving us leaflet, but we don't know who are people conducting the research, where the funding is coming from. So they were telling us they would like to they would like to see people coming and talk in the community, and we found that it is really helpful if we go just have a face-to-face connection with them. Language barrier is another thing. So we are hoping that by raising awareness, for example, similar to NIHR calls, we have in different grant application, we have this opportunity to apply for funding for translation. Cultural requirements, different community, they may have cultural barriers. I talked with a lot of women that they were happy to attend BCI research, but they asked me, can we have a private room and a female experimenter to collect signal from us? So we were happy to take off the scarf. A stigma in brain research is another thing. So for example, if you are conducting a research to understand depression, people may hesitate because they have this fear that if I attend in my community, I might be labeled as a person that I have depression or other brain diseases. Again, this is a wall, this is a barrier that we need to work on it. Trust, history of marginalization, this is another thing. And generally what they mention is that there is a lack of engagement between researchers and community centers. So what we learn is that we need to go to the communities and we need to get connected with the community centers and build up this trust gradually and gradually. But the question is that can we record high quality brain signals inside the communities rather than in our laboratories? So this is something, a new challenge that we feel that it needs to be addressed. So what we did is that in the Somalian community, we tried to see if we can conduct a BCI research inside the community. So we conducted a number of workshops. So the first workshop, it was just introduction about the research we do, about EEG devices, FNIRS devices, and what we do in our lab. After we build up this relationship and trust, we recruited 10 people, 5 men, 5 female, to attend BCI research. And thereafter, we got back to them and we talked about, what we learned, what we found about the barriers, which areas need to be improved, how we can make our brain research more inclusive. And here I would like to show you the results that we had. So we asked these 10 participants. So just, I would like to say this is just a small cohort. We don't want to generalize it, but this is a small cohort that after one session, they came to us. Was very interesting for me that at the beginning, some of them were really concerned about safety of the EEG device, safety of FNIR's device. But after trying it, after using and after doing experiment, all of them, they felt that it's absolutely safe. So it's really important for these participants to have this opportunity to wear and try the equipment. Comfort of the experiment equipment, they got mixed result, but mostly positive. One participant was complaining about gel-based, which we know this is the challenge that we have with EEG. Ease of instruction, this is something. And the other thing that I would like to show you is about concerns about privacy. This is about another thing that they were really concerned, how we handle the data. And you see that before the experiment, a lot of people were much more concerned, but after experiment, when they saw, all the steps, what we record, what we don't record, they get more confident about EEG device. And they were more also willing to attend future studies and also recommend these participation in these sorts of research to their friends and family members. We also compared the quality of the signal that we recorded in community compared to the quality of data that we recorded in our lab. And you see, as we expected, the quality in lab, we had less artifact corrupted trials. We had more artifact corrupted trials in community, but still the data was usable. So on average, we got something like 70% of trials we could preserve, but also we learned about how to avoid in future. We found that we need to give more time between one session to another sessions. We need to make sure that we signpost the room, making sure that nobody opens the door at the middle of the experiment, because it's all these things that we learned how to ensure that we are going to have higher quality signal. But I would like to say these people, they had curly hair. So one reason for lower quality was that, again, we were recording from the community that they had a lot of them, they had curly, thick hair. We also here, you can see so it was a type of rapid visual presentation task. So it's like a P300 task. We looked at target versus non-target accuracy of our classification system. In our lab cohort, we got accuracy of 70%. Community cohort, we got even better accuracy, 74%. And for all participants, we got accuracy above chance level. So it by itself, it shows us that we can get meaningful data and also meaningful BCI classification accuracy if we transfer our equipment inside the community and we do the data collection. And it might be one way to explore to increase diversity of our data sets. So you may tell me that, okay, these are all in the research stage. When something gets to the clinic, all these problems are already solved. But I would like to tell you that we have even disparities in adoption of neurotechnologies that all are already available in clinic. And one of them is deep brain stimulation that is used for managing symptoms of Parkinson's. So Parkinson's disease is a neurodegenerative disease, is a progressive disease that it affects movement and motor. It is because of loss of dopamine, and which is a neurotransmitter, and there are a number of symptoms, but tremors, shaking hands, and muscle stiffness, slow movement. They are some of the symptoms of this disease. Usually, sorry. Okay. Okay. Usually this problem, sorry, it is okay, so one of these patients usually start taking medication, but after a few years, the medication doesn't work anymore. And for some of these patients, deep brain stimulation is is prescribed. So deep brain stimulation is electrodes. They put electrodes inside the brain, and it can shut down. So it doesn't cure the disease, but it can shut down those irregular brain activities, and it can significantly improve the quality of life. So I don't know if you can see this video, but the deep brain stimulation is off, and it causes a lot of tremors. But when the deep brain stimulation gets on here, you see that the hands are steady, the person can do a lot of, much more precise activities, for example, pressing fingertip movements, something that if you compare with the time that the deep brain stimulation is off, it's not possible. So it can significantly increase the quality of life. Let's go to the next slide. It can significantly increase the quality of life. We have 10 centers in the UK providing deep brain stimulation. But the problem that we have, so this is a technology that is working really well, but the problem that we have is that women are significantly underrepresented in DBS adoption. So there are limited studies, but the studies that we see is that it's 2 hospitals in Germany, 2 hospitals in the UK, and they observed that women should have more severe symptoms to be offered in DBS center. And although men and women, both of them are benefiting similarly from DBS, but the chance of women saying that we don't want this treatment, that it's more likely for women to say that we don't want this treatment. We have also huge disparity in adoption of DBS among Black people, non-white people. We are looking NHS health record data. We don't have it yet, but we got the ethics approval to look at NHS health record data, but we have stats from the US, and they try to make, look at all the they try to take into account all the economical, social factors, but still they saw that a white person is 5 times more likely to receive DBS compared to a non-white, a Black person. So we try to understand what are the issues for this disparity. Why a technology that is even working really well, but there is a disparity in adoption of this technology. And it can be any part in the cycle of care. So it's not only in terms of the decision making and DBS center, but it can be any part of the cycle of care. So we conducted a survey with the help of Parkinson's UK. We have, very quickly telling you that something like around 261 participants with Parkinson's completed deep brain stimulation. 39 of them, they already had deep brain stimulation implanted. Sadly, still our sample is not diverse. We only have something like 9% non-white participant, although we went to even local events to make sure that we make our sample diverse. But at least in terms of men and women, we represented the prevalence of the disease, and we tried to look at what are the barriers. And it seems that the main barrier for adoption of deep brain stimulation is a surgery. This is something that both men and women, they notice that is a big barrier. But the other thing that it was perceived more by women rather than men is that it was not only about technical, it was not only about how they work in terms of improving motor control, but it was about side effects that are hidden. For example, affecting speech, affecting cognitive, affecting emotion, affecting the feeling of being self. So these issues were significant, these concerns were significantly higher in women than men. So what I try to say is that as engineers, as people who are doing brain-computer interface or working on neurotechnology from the first stage, these are the issues we need to consider, that if we would like to have a technology to be adopted, so we need to consider these concerns that people have. Surgery would be one of them, but also cognitive side effects that usually they have not been analyzed, that they have not been seen a lot. You may tell me that, okay, in brain-computer interface, we do closed loop. So a lot of biases, those things our model considered, so we shouldn't be worried about. But still, I'm worried about non-invasive, the invasive BCI, implantable BCIs. There are a lot of clinical trials, implantable BCIs across the world, but I can say that we have persistent underrepresentation of women. And also we have this culture, we don't report the demographic of our participants. So I looked at all, implantable BCI trials from BrainGate, from Switch, Neuralink that we know now. They are conducting clinical trial in US, UK, Canada, in Emirates, and it's except one of them, the other ones they didn't report their demographic. And majority, I can say more than 80% of the participants in invasive BCIs, in implantable BCIs, they are men. So we rarely have women participants. And again, if you look at the blood-brain barriers and how hormone fluctuation in hormone level may affect, so there are variations between men and women that it needs to be considered in the earlier stage of the design. So I would like just to summarize what I presented is that we try to raise awareness, and we would like to work with you as researchers to make sure that the neurotechnologies that we design, they are inclusive. And because of that, I think we need to make sure that we have our data sets as diverse as possible. We are working a lot on nowadays AI, and we try to use AI more and more in BCI research, but we need to ensure that our data sets are as diverse as possible. Otherwise, we see in other examples that AI models are biased toward a specific, it can be biased towards some specific anatomical factors. So these are the parts that we are working towards, and I can just summarize that in this part we try to talk about. So we didn't cover about other factors affecting access to this technology, but we try to look at design biases. We look at lack of diversity in research participation, and also barriers in adoption of the technology. So very quickly, I would like to thank the team of Neurotech4All. You can get more information in our website, but please be in touch. This is something that it cannot be done by one team. I think it's the entire community. We need to work together and acknowledge the barriers that exist, and we try to put our efforts together to ensure that we get enough support, financial support, but also support from clinicians, from other researchers, to ensure that we can increase diversity and inclusivity in BCI research. So I think that's all. Thank you so much.
Thank you, Mahnaz. This is really interesting. Yeah. You can hear us?
Yep. So I'm happy to answer the question.
Okay, good. So you can hear me, right?
Yes.
Okay, so thank you very much. This is very interesting, and indeed it's something that is so important, and nevertheless, most of the time, we tend to ignore these issues, and definitely this is not helping our technologies to translate. So please, if you have questions, just feel free to unmute and ask directly.
Well, hi, Mahnaz, and thank you for the presentation. It was very interesting. And as Simi said, definitely we kind of all know that we should have more representative data, but we just pretend, to do the easiest thing, especially what I'm talking for myself, is just recruiting university students for our BCI experiments. Typically, at least in my case, I don't do any clinical or rehabilitation research, but still, yeah. No, just in general, I wanted to ask you about evidence. So yes, well, you have been talking especially about accessibility, and but At the beginning, you were also talking about the data that are collected, the EEG and brain data in general. They are mostly from white and people. So my question is there evidence? Well, I'm interested in knowing if there is strong evidence about, or any type of evidence about whether actually, like for example, for a BCI, there are differences in terms of, I don't know, brain signals or accuracy, or what type of BCI are more effective, not just in terms of differences in, based on ethnicity, but also age.
That's a very good question. Thank you so much, Katrina, and nice to meet you again. So the challenge is that so we don't have any these sorts of systematic analysis to see, okay, are there any evidence to show that, for example, our brains work differently? And I'm not trying to add to talk about, but what we observe is that, for example, our signals are noisier, and I think all of us in the community agrees that even when we collect data in our lab and we have female participants with long hair, or even, and participants, it doesn't matter female or male, but those who have long curly hair, the quality of the signal is lower than the other ones. We try to compensate with our signal processing, machine learning algorithms.
Yeah.
But in a long term, I'm thinking about, okay, if we have a technology that wants to use 24 hours outside of the lab, or it can be used for rehabilitation, does it mean that the person with less hair, for example, benefits more of that rehabilitation compared to another person that has curly long hair? So this is something that we don't have evidence yet. What we have is more anecdotes that we talk with each other. Or sometimes some of the labs I call with my colleagues, they say, we have really expert researchers that they can collect high quality signals, but yeah, it takes more time. They came with really nice breathing skills, or how to open the, use take the hair away. But this is again another issue. It means that for some participant, the setup time is just 5 minutes. For some other participant, the setup time might be 15 minutes, 20 minutes. So the way that they experience the technology, it would be very different. And but there's not any further. These are all that we learn, and because of that, I'm thinking that there is a need for us to report demographics in our research. So if there are any issues, any barriers, or any systematic differences, we can later do some sorts of systematic analysis, some meta-analysis to figure out those differences. But I know the constraints for ethics approval, but we never report these sorts of metadata. And you mentioned about aging also, that it can be the same thing. So I recognize completely the difficulty of gathering diverse data sets, the difficulties of reaching out to these community centers. But what I feel is that we need these difficulties should be recognized by funders, for example, and they can provide us more financial support. If, for example, I need both men and women experimenters, if I need a private room, if I need to travel to community centers to do the EEG experiments, so financially we need more support. But also there are really great initiatives that I see that they work globally to record open access data. And I think this is also a great thing. So we work with different countries, different institutes, not only European countries, but also beyond that, to ensure that the brain data that we have, they are diverse, but also openly we share this data set to each other to ensure that, for example, the AI models that we develop, they are working across multiple data sets.
Yeah, that is a big issue, actually. Yeah. Okay, thank you very much.
Thank you. Is there another question?
So is it actually part of this Neurotech4All project to quantify the gap between, for example, setup times needed for someone with, curly African hair compared to someone with no hair? Or what's the next step there?
So it's not one of the main deliverables. So we didn't promise that we do these things to quantify this one. But I think this is also something, if it raises the awareness and it shows the gap that we have, I think that's a really nice idea. I'm aware of a number of companies that they are developing different types of electrodes, more flexible electrodes. Also, it's really interesting to work and see how, for example, their innovation can compensate this setup time. It can, with the same setup time, if they can achieve similar qualities. So to me, in many cases, again, it is just based on my experiment. It's not any quantified research, but a lot of solutions are not very difficult in terms of engineering perspectives. A lot of solutions in the design biases are because of lack of awareness or lack of recognition that this problem exists.
Thank you. Any other question? If not, I have one that you have luckily kind of already touched upon in your response to Katerina's question. So in my view, this is a little bit political. So in my view, many of the problems you presented today really boil down either to lack of funding or even worse, to the general income inequality among ethnicities, among genders, and so on. So, and I'm saying this to give an example. For instance, what you already replied to Katerina, a company, especially if they are targeting the European market, where most people won't have the curly afro hair, right? It is for them extra cost to do extra research to design electrodes appropriate for these people. So they don't have financial incentive, and companies do it for the money, right? So unless they get subsidized by the state or by the European Union, whatever, this simply won't happen. Or regarding access to DBS, for instance, or other neurotechnologies for Parkinson, for whatever, women are not there because of the income inequality again. Like they are less likely to be able to afford it, or maybe even to have medical insurance to cover it, and so on and so forth. So given that, do we see any solution? Because if it really boils down to solving much wider and much more difficult to solve societal problems, what is the solution? How can we go ahead and get unstuck?
Okay, thank you so much. I fully understand what you mean. But something that is really interesting, for example, you mentioned about deep brain stimulation, and with this challenge that we have, and we have it in the UK, it's offered for free. So all the costs are covered by NHS, but still we have disparities in adoption of this technology. So now this is coming to these cases that, okay, maybe the first thing that I can say is that in all stages that we design a technology, we work in a research, we need to involve patients, we need to involve people to make sure that what we develop, they are, as they consider the needs of all the patients. Yeah. But when you talk about this challenge and this problem, I can talk about a lot of, you talk about these companies, but I think these companies, they are playing a huge role in addressing this gap, this problem. I can name, for example, this Open BCI. They made BCI device accessible in a lot of African countries. They even, I was in one of the technologies that they were telling, and they made the code, everything accessible, the training accessible. So researchers in low income countries, they can get access to these devices. and to do the research. But at the same time, for example, for European labs that are they might not have any financial problem, but they still are interested to use these devices because they would like to take this BCI technology outside of the lab. So to me, I think startups are really playing really good role in filling the gap, because they always have this vision that I would like this to be used outside of the lab, outside of the clinic, in day-to-day life, and we would like to make it accessible, cheaper, which at the same time, it means that even labs with less financial support, they can get access. So I'm really optimistic as long as we acknowledge, and hopefully we can get funding enough. If it raises awareness, we can also request it. It should come up as a very odd thing. We request more money because we would like to go to the community centers and do the research also. So I agree with what you mentioned, but I feel that startups, they can be really helpful.
Okay, thank you. Yeah, I hope you're right, and maybe I'm a little bit too pessimistic here. All right, one final question, I guess. With respect to the project, the ARIA project you are presenting, what kind of neurotechnology? So, what is the range of neurotechnologies you're supposed to canvas and so on? Is it EEG? But also invasive, I understand, interfaces and brain stimulation?
It's a very broad range of technology, but specifically, we are working with the projects that are already funded by ARIA. So we try to ensure that from the first day that they do research, they make sure that they consider anatomical factors that affect their technology, and it's a very big range of technologies. They have some of them based on gene therapy, tissue, focused ultrasound, TI. So EEG might not be, but magnetic based, TMS. So it's a big range.
So it's like an umbrella project supposed to interact with the other. I know that ARIA funds a lot new kind of interfaces. That's one of their main things, right? So, okay. Are there any questions?
Well, it's not a question. It's more like a comment about the DBS data that you showed us, the disparity between the gender disparity in accessing DBS. And I'm wondering whether there is well, I was just thinking about it because I found it that very surprising, because typically women seek for medical therapies and stuff more easily than men. And I'm wondering whether there are maybe two things. One is that men maybe generally keener on technology, and also if there is on the other side, well, because now we know there is a lot about doctors and consultants having being biased toward providing more, taking medical problems more seriously in men than women. Whether there is also this factor in this case, but yeah, just a comment.
Thank you so much. Sorry, the problem with voice is coming back and go, but based on what I understood, you talked about, I agree with you. We didn't, even in our survey, we didn't see any difference about openness to technology. But as I mentioned, there are different factors. When I was talking with clinicians, because deep brain stimulation has an interval. So if that interval passes, so for example, it's not offered for people above 72-year-old, or sometimes 70-year-old. So if you miss that interval, it's not going to be offered to you. And for example, there are studies showing that women are diagnosed late because sometimes the symptoms are mixed up with menopause. And this delay in diagnosis might be one of the contributors also. So it's not always anything about openness. to the technology. Sometimes we need to even go one step back and look at, okay, the problem might be in the diagnosis. They get diagnosed late.
Yeah.
There might be even in a real case, we need to look at the entire cycle of care to see the differences. But
Yeah.
one of the areas that this survey tries to, because there's a survey that covered, with, it was directed as a part of ARIA project. So the aim was to give them some guideline that, okay, future technology, what aspects should be considered for the design. And what we learned is that, okay, for example, how it may affect cognitive performance is also important. Not only improving, for example, tremor is important, but there are a lot of, when I talk with patients, access to neurologists is a big case. In some regions, patients with Parkinson's are not seen by neurologists. They just see with general consultant. And those regions, they are usually not offered to the DBS center. This is again another part that can affect the case. Generally, for getting DBS, there are 1 year assessment that they assess everything to see if the person is eligible for DBS or no. And imagine people who have disability and living far from the DBS center. So if you are in Wales, you need to go either to London or Liverpool. So this travel might not be feasible for everybody. So unconsciously they get behind this treatment and all these things. So a lot of factors affecting.
Yeah, it must be very complex.
And maybe it's not the case about us to, to see what is wrong about DBS, maybe thinking more about, okay, so there is a need for a more accessible, there is a need for something that is less invasive, so that it doesn't have an age limit. So people after 70-year-old can be also prescribed for them, or it doesn't need a lot of multiple pre-assessment and surgery before that. So people who are far from the centers, or it can be delivered in any hospitals rather than super specialized hospitals.
Yeah.
All right, thank you very much. Our time is up, so I think we can leave it here. Mahnaz, thank you very much. And
I do really apologize for keeping you
No
waiting
problem at
for
all.
all those technical issues. I really apologize, but
No
I
worries.
really appreciate your time listening to what I said. And please keep in touch if you're against,
Of
you're
course.
anti, just let us know, because I think it's something that we are building as a type of initiative. And I think it's something that in our community, we need to work together, address it, and any experience, any good practice that you know, I appreciate if you share with us.
Definitely, we'll be in touch. Okay, thank you. Bye-bye.
Thank you so much.
Thank
Thank
you.
you. Bye.
Bye.
Bye.